Assalamualaikum and good day to all panels. My name is Nur Shakila Inani and I will be presenting on the project titled Laser Beam Wobbling Technology for Precision Manufacturing Techniques. This project has been led by Mr. Zawani bin Ismail and the other co-inventors are myself, Nur Shakila Inani binti Ahmad Rosni, Dr. Muinuddin Muhammad Qazi, Dr. Luqman Hakim Ahmad Shah, Dr. Aiman bin Muhammad Halil, and also Professor Dr. Maharzir bin Ishaq. So first, I will talk about the agenda for today's presentation. First, I will start this presentation by talking about the current scenario, and then laser wobbling application, and the next part is challenges and future welding outlook. Next is the current joining processes, and then moving on to the monitoring and software capabilities, and the last one is ongoing joining and welding activities in UMP. So first, let's talk about how our rapid industrialization has growth, and this actually being one of the cause towards our climate change. And climate change is also known as the global phenomena transformation characterized by the changes that mainly caused by human beings. And examples of the climate changes such as sea level rise, and then the ice mass loss in Greenland, Antarctica, and also an extreme change of weather. This is not surprising because it is clear that manufacturing operations are most likely affect our climate change, and this results in the most significant greenhouse pollution such as carbon dioxide, and our major contributions is the transport sector. We has been introduced by the electric vehicles, or also known as e-mobility, and this is new in our automotive industry. And by introducing this type of vehicles, it actually can help to contribute towards a healthy and more stable environment, because we know that car produce a lot of carbon emission towards our atmosphere, and by if we want to reduce those pollution and to positively help our environment, electric vehicles is one of the good option for us to move forward. The study shows that by 2025, sales of ultra-low carbon vehicles are projected to increase. The data has been compiled from Bloomberg Energy Finance by Haley Glibery. It shows that an increasing pattern for the electric cars expected to be sold, and when the number of car manufactured is increased, then the demand for the battery will be increases too. By using laser wobbling welding for e-mobility, it will increase the efficiency to produce a high-demand product, as laser welding is one of a very fast technique and time-consuming. Laser beam welding is an excellent choice even for a small components and assembles. Examples can be found in precision engineering or electrical contacting, such as hairpins for e-mobility, and this requires generally very precise and automated recognition of the welding position, as well as the laser beam welding with beam oscillation. Moving on to the introduction of wobbling technology. So basically, laser beam wobbling, or also known as LBW, is a novel technique in which the laser beam forms a high frequency circular motion while translating through the welding workpiece. This is the video where how does the wobbling technique operate. So basically, the wobble effect is produced by high-frequency wobbling rotation of the laser lens. And some key breakthrough using this technology is the ability to weld difficult alloys without fillers and to form dissimilar welds. What is the issues that occur in micro-joining technologies, which is distortion. The large welding distortion easily occurs in the ultra-thin metal structure after the welding process due to low stiffness and the uneven temperature field. And some of the causes towards distortion, such as parent material, amount of restraint, joint design, part fit up, and also welding. The first is parent material properties, which influence distortion, are coefficient of thermal expansion and specific heat per unit volume. Next is the amount of restraint. If a component is welded without any external restraint, it distorts to relieve the welding stress. Joint designs, such as both butt and fillet joints, are also prone towards distortion. And next is for part fit up. Fit up should also be uniform so that it can produce a predictable and consistent shrinkage. Excessive joint gap can also increase the degree of distortion by increasing the amount of weld metal needed to fill joint. Last but not least is the welding procedure. It will influence the degree of distortion, mainly affected by the power density, heat source parameter, and also the welding speed. And these are the image where laser energy produced when high heat input. And also we had observed some distortion on these plates. Next is the application of laser welding on battery components. Yes, for the first one is the E-drive hairpin welding. Next is copper aluminum joining. And the third one is joining of battery cans. And for the last picture is the welding of battery housing. So we are going to continue this presentation by showing our result of the product that can be made with wobbling technology. So a significant number of experiments were carried out to obtain a smoother and defect-free weld seam, and it was found out that wobbling distance and wobbling diameter were the most significant parameter that can affect the quality. So the precise control of wobbling parameter is extremely important in the welding technology. Here are examples of how bipolar plates that are used in the construction of hydrogen fuel cell. The plates are required to be joined together for a proper cooling for microchannels created, and this requires intricate joining in the dimension of a few hundred of micrometers. And with laser wobbling technology, this can be achieved, and a very thin and accurate joints can be made between the plates without any form of angular or warpage. And here are the example of the bipolar plates that are joined together. Next, I will present the advantages of wobbling technology, especially in preventing and controlling distortion, which we wanted to avoid, especially in welding. And on the left-hand side, you can see that the plate has joined using laser welding hatching technique and have a distortion of about 3 to 4 millimeter, while on the right hand side we can observe a closed and sealed joint without any form of plate displacement. Laser wobbling can also be used to join battery plates, cans, casing, and bus bar connection. So here we demonstrate a lithium polymer battery with its anode side being connected with a strip or foil of 200 microns of SS304 steel plate as an alternative to bus bar connection. And the inset in the right hand side shows spot welding with wobbling, and with a strong joint is formed.